Hello everyone, greetings to all. Myself M. Kavitha, working as an assistant professor in the Department of Computer Applications, Heber College, Trichy. Now I am going to take on the subject Fundamentals of Deep Learning. In that, the topic I have chosen for my presentation is Mathematics for Deep Learning. Under the mathematics for deep learning, the subtopic is geometric and linear algebraic operations. Linear algebra is essential for many deep learning algorithms and techniques. It helps in manipulating and processing data, which is often represented as vectors and matrices. These mathematical tools make computations faster and reveal patterns within the data. It simplifies complex tasks like data transformation, dimensionality reduction, and optimization. The key concepts like matrix multiplication, eigenvalues, and linear transformations help in training models and improving predictions efficiently. Next, let's move on to the fundamental concept in linear algebra for deep learning. In deep learning, the terminology of linear algebra are vectors, matrices, and scalars. It's play key role in handling and processing the data. The features of these three components enable efficient computations, patterns recognition, and model training in deep learning. A vector is a fundamental mathematical object. It is the effective way to organize and store objects. It is an one-dimensional array of number. Next one is matrices. Matrices are rectangular array of numbers. It's arranged in row and columns. It represents linear transformation systems of linear equations and data transformation in machine learning. In deep learning, scalar is a single value, numerical value. It's representing magnitude without direction. Let's consider a scalar k value equal to 3 and vector v. It's multiplying each component of scalar value 3 by the vector values. Finally, we obtain this result. Next, we are going to see about operations in linear algebra. The operations are addition, subtraction, scalar multiplication, dot product, and cross product. Let's we see each of the operation in detail. In addition, we are adding two different U and V matrices. For subtraction, we subtracting the corresponding U minus V elements. Scalar multiplication involves multiplying each element of a vector or matrix by a scalar value. Third one is dot product. This is also called as scalar product. Here we are multiply the matching elements of the vectors and then add them together. The last operation is cross product. Another name of this cross product is vector product. The cross product involves two three-dimensional vectors. It makes a new vector that points at a right angle to the right original vectors. Now we will discuss about common linear transformation in machine learning. It's help to manipulate data in useful way, make it easier for model to learn patterns and predictions. Some common linear transformations are translations, scaling, rotations. First one is translation. A translation transforms simply moves every point by a certain amount of horizontal and certain amount vertically. This is the pictorial representation of translation. Second one is scaling. It transforms can be used to make object bigger or smaller. Last one is rotation. It rotates each point about the origin 0, 0. Every point rotate through the some angle. It is called the angle of the rotations. Next is geometric and linear algebraic operation. Linear algebra is one of the key mathematical pillars in deep learning. A vector is being denoted as list of values and it's mostly written as either column or row vectors. This shows how being denoted. Two common geometric interpretation of vectors are points and directions. This diagram shows how vector can be seen as point on a graph. Here the graphical horizontal line is x-axis and the vertical line is the y-axis. The point 1, 2 means it moves one step right on the x-axis and it's moved 2 steps up on the y-axis. The point 3, 1 means it's moved 3 steps right on the x-axis and move 1 step up on the y-axis. The point -2, 2 means it's moved 2 steps left on the x-axis and 2 steps down on the y-axis. Each point x, y represent a vector that shows a position in space relative to the center called origin 0, 0. This diagram shows vector as arrows that represented direction and movement in the space. The vector 3, 2 means it's move 3 steps right on the x-axis and move 2 steps up on the y-axis. The arrows in the diagrams show the same vector 3, 2. They all have the same direction and length, just starting from different points. This means a vector is not just a point, it also shows how to move from one place to another. This diagram shows vectors addition using arrows. A vector represents movement in a certain direction. To add two vectors, start at the origin and follow the first vector direction. Then from the end of the point, follow the second vector's directions. The final position after both steps give the sum of the two vectors 3, 1. The dashed lines help show the path step by step. Vector subtraction. When subtracting two vectors u minus v, we find the direction from v to u. This means u minus v is the vector that moves from point v to point u. The main purpose of geometry vectors in deep learning is to represent data in a mathematical way. It helps computers to understand and process data. It enables neural networks to learn and make decisions. Finally, it provides a way to visualize and understand complex data and models. Thank you.